Welcome back. So remember, we last learned about point-slope form, where we still have our x and our y along with our slope, but now we're being given a point and a slope. What if we are asked to write our equation in slope-intercept form? Remember, slope-intercept form is really helpful when we want to try to graph or solve a problem. Point-slope form isn't necessarily helpful for those things. But what if we're given the slope and a point? What do we need to put this in slope-intercept form? Well, we need the y-intercept, which we don't have. So we're going to start with a point and the slope, but we're going to finish with an equation that's in slope-intercept form just by using some inverse operations. Let's give it a try. So what we've got here is a slope and a point. Remember, this is our x1 and our y1. Remember, we got to start here because we have a point and a slope, so we need to use point-slope form. The problem is we're being asked to get it into slope-intercept form. Well, let's start just like we did before and substitute into our blanks. The y value is 3, the slope is 2, the x value is 1. Well, I noticed that slope-intercept form doesn't have any parentheses, so I'm going to distribute to get rid of those parentheses. So we have y minus 3. Remember, distributive property is multiplication, so that's 2 times x and 2 times negative 1. We're close to having this in slope-intercept form. We've got a number with an x, we've got a number by itself, but remember, y has to be isolated and it's not. So instead of being done, we have one more step. We're going to add 3 to each side. Remember, we can only add and subtract things that are like terms. The 2x and the 3 are not alike. I probably shouldn't have put the 3 underneath that 2x. I want to put it over here because these two are like terms. Negative 2 plus 3 is positive 1, so it becomes 2x plus 1. Now, if I wanted to graph or solve a problem, I would have this in slope-intercept form. I would know what my y-intercept was, and I would know what my slope was. For this one, we've got, again, a point and a slope. So we have to start with point-slope form. We can't jump straight to slope-intercept form because we don't know the y-intercept. So this becomes y minus negative 2 equals negative 4 times x minus 3. Does anybody remember what we did before when we saw this minus a negative? We go ahead and do keep, change, change. So this becomes y plus 2 equals negative 4 times x minus 3. Remember, we did what did we do here when we wanted to get rid of our parentheses? We distributed. So we're going to do the same thing here. We're going to do y plus 2, bring that down, equals negative 4x plus 12. We're going to subtract 2 from each side. The 2's cancel out, so y is equal to negative 4x plus 10. Again, if I wanted to graph, now I know my y-intercept is 10 if I need it, and my slope is negative 4. Good job. So remember, if we want to write our equation in slope-intercept form, we start with point-slope form. If you haven't written that down in your notes, you're going to want to do that now so that you have it in front of you when you're doing your IP. And end in slope-intercept form. Do one more together, and then you're going to try one on your own. Remember, we have a point and a slope. This is our x1, this is our y1. We're going to substitute into these same blanks every time. The y value is negative 3. The slope is negative 3. The x value is negative 4. Clean up your minus negatives before we move on. Y minus negative 3 is the same thing as y plus 3. And x minus negative 4 is the same thing as x plus 4. Do not distribute until you've cleaned those up. Now we're ready to distribute. So we have y plus 3 equals negative 3x minus 12. And then we need to isolate y. So almost every time we're doing the same thing. Clean up your signs, distribute to get rid of your parentheses, and isolate y. Check with your calculator. Negative 12 minus 3 is not negative 9. It becomes negative 15. I want you to pause the video and try this next one on your own. Welcome back. You should have started by noticing that you had a point and a slope, so you know you have to start with point-slope form. The y value was 7, the slope was 3, the x value was negative 2. So we're substituting into our equation first, getting rid of our minus and negative, so that's the same thing as plus a positive. So again, I'm not going to distribute until I've cleaned up my signs. Now I'm ready to distribute. Y minus 7 equals 3x plus 6. Add 7 to each side to isolate y. Remember, we only add things that are alike, so 6 plus 7 becomes 13. I do not add the 7 to the 3x. Good job. Try another one. Y minus some y value is equal to the slope times x minus some x value. Remember, this is my x1, this is my y1. The y value is 5. The slope is 1/2. The x value is 4. Don't panic when you see fractions. We can still distribute just like always. We bring down the y minus 5. 1/2 times x. I don't need to panic. I just put the 1/2 in front of the x. And then if you need some help, go over to the side and think about what is 1/2 times 4? Well, remember, we've learned about canceling before. We're multiplying a fraction by a whole number. We can divide what's on the bottom. 4 divided by 2 is 2, and 1 times 2 becomes 2. Now we just add 5 to both sides to isolate y. So y equals 1/2 x plus 3. By the way, if you would have rather gotten rid of your fraction by multiplying everything by 2 on both sides, you're more than welcome to. Again, you have a slope and a point, so we need to use point-slope form. So we do y minus y1 equals the slope times x minus x1. The y value is 1, the slope is 2/3, the x value is -9. Go ahead and pause this on your own and see if you can finish from here. Welcome back. You should have started by cleaning up your signs before you distributed. Remember, it's not hard to multiply the fraction times the x because you just put them next to each other. You can go over to the side and think about what we're doing when we multiply 2/3 times 9. Remember, we're dividing by what's on the bottom and multiplying by what's on the top. Now we isolate y, add 1 to each side. So y equals 2/3 x plus 7. Nice job. Let's try another one together. Again, we have a point and a slope, so we have y minus the y value equals the slope times x minus the x value. We have y minus -3 equals -4/5 times x minus 10. Remember, I'm going to do keep, change, so that becomes y plus 3. I just put the -4/5 in front of the x. If you need to, you go over to the side and you think about what -4/5 times 10 is. Remember, we cancel what's on the bottom, multiply by what's on the top. But notice it's a negative times a negative, so that becomes a +8, not a -8. And then we subtract 3 from both sides to isolate y, so we get -4/5 x plus 5. Pause the video and try this one on your own. You should have first labeled that you have your x1 and your y1 and left yourself blanks to fill in to the point-slope form. Your y value is -9, your slope is -3/4, your x value is 12. Don't forget to do keep, change. That gives us y plus 9. Now we're ready to distribute. That becomes y plus 9 is equal to -3/4 x. Go over to the side, think about how to multiply times -12. Those cancel. A -3 times a -3 is a +9. We subtract 9 from each side, so y equals -3/4 x plus 0. That doesn't mean no solution. We can have a y-intercept of 0. Zeros are real numbers too. Don't discriminate. So let's review. Let's think about all 3 forms that we've learned. I want you to pause the video and I want you to think about whether each of these equations are in standard form, slope-intercept form, point-slope form, or none. Go ahead and pause the video and do that now. Well, let's look for slope-intercept form first. Remember, on slope-intercept form, y should be isolated. So I see that number 3 has y isolated, then a number with an x plus a constant, so that should have been slope-intercept form. Number 6 also has y isolated. It's got a y by itself, a number with an x minus a constant, so that also was slope-intercept form. I don't see any others where the y is isolated. Number 5 can't be slope-intercept form because it's got the -2 in front of the y, so that one doesn't work. But maybe it's one of the others, so we will push pause on that. Let's look for anything that's in standard form. Remember, standard form looks like ax plus by equal to c, where we don't have any fractions, we don't have any decimals, and a has to be positive. Number 1 is a perfect example of standard form. Number 2 at first glance looks like it might be, but the y is on the wrong side. The x and the y need to be on the same side in standard form. In number 4, we definitely shouldn't have any parentheses or fractions in standard form. Number 5, the x value is on the wrong side. Number 7, again, there's those parentheses. That can't be standard form. Number 8's a maybe. We've got a number with an x minus a number with a y equal to a number by itself. Yep, that one is standard form. Now let's look for our new one, point-slope form. Remember, point slope form has those parentheses. So number 2 must be none. We've already tried slope intercept. We've already tried standard. It's definitely not point slope because it doesn't have any parentheses. But let's look at 4. I see some parentheses here. I've got a y plus some other number. I've got a number in front of the parentheses for the slope. Yep, this one is point slope form. This one has to be none. It wasn't standard. It wasn't slope intercept form. There's no parentheses, so it can't be point slope. Last one we have left, number 7, we've got a y with some value equal to the slope times x plus some value. Yep, definitely that is point slope. Good job. All right, so before you do your IP, you want to be able to identify point slope form, slope intercept form, and standard form. You want to be able to substitute slope and a point into the slope intercept form. You want to be able to distribute and use inverse operations to change from point slope form to slope intercept form. And you want to be able to distribute a fraction and describe your steps in the process. Remember, we start by substituting into point slope form, we distribute, and then we isolate y. Right now, you're going to go back to Haiku and click on the link to work on your IP. Remember, do your best, use your notes. If you have any trouble, I have office hours every day, Monday through Thursday from 11 to 12, or by appointment. I would love to see you. Bye-bye.